Thanks for watching this 7th video in a series of work solutions for Edexcel GCSE Computer Science, helping you prepare for and revise for Paper 1. In this video we're going to go through how to get to the answers for question 2c, which we introduced in the last video, all about run length encoding and Caesar ciphers. And then your challenge at the end will be to have a look through and attempt question 3a, which is about network topologies. So let's have a look at that question 2c again. This is a multiple choice question. So there's a mistake in this version that we're looking at. This question is only worth 1 mark to identify one reason why run length encoding has been used. So in a multiple choice question, you want to put a cross through the box that the one you think is right. But if you make a mistake and you change your mind, you just put one line through it and then you put a cross through the one that you then think is correct. So in this case, there's only one that makes sense. RLE is a compression algorithm. The whole point of compression is to reduce the size, the storage size, the number of bits that it takes to store that data. So the correct answer here is to reduce the storage space required. Then we move away from run length encoding, we'll come back to that later in the paper, onto Caesar ciphers. So the drone can also be operated by Wi-Fi as long as you know the right password, and the password stored on the device encrypted using Caesar cipher algorithms. So if you have a question about Caesar ciphers, I'd always recommend just writing out the alphabet to begin with. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, just because if you're under pressure in the exam, this will help you prevent making silly mistakes. The idea of a Caesar cipher is that you take every letter, so for example we start with an A here, and we shift it along by a set amount to get to the ciphertext. So a Caesar shift of 0 would mean that an A stays an A, a Caesar shift of 1 would translate an A into a B, or a 2 would make an A a C, a Caesar shift of 3 would make an A into a D. So your ciphertext is going to be D for the A, and then from D we go 1, 2, 3 to a G. This is why it's worth writing this out so we don't make any silly mistakes. M is going to be 1, 2, 3 P. I is going to be 1, 2, 3 L, and then N is going to be 1, 2, 3 Q. So if you want to double check, just make sure your plain text has the same number of letters as your ciphertext. This time we have to work backwards, so we've got 1 mark so far, assuming that we've got this right. D, G, P, L, Q. Yep, that looks right to me. It doesn't matter if your ciphertext is in capital letters or lowercase, that's fine. Then we have to go backwards, so the ciphertext is O, we need to get back to P. So to get from O to P, we would shift a +1, but remember we're going in the opposite direction this time, because we're going from O to P, as in the original was P, we'd have to go back 1 to get to this ciphertext of O, so this shifts a -1. 1 mark for each. The minus just means you're shifting left, as in you're going backwards in the alphabet. A positive shift means you're going forwards in the alphabet. Then, so we get 2 marks here, 1 for each. A security researcher finds an abandoned drone in her garden, and she's able to read the encrypted ciphertext, so that's this column here, by plugging it directly into a laptop and inspecting the data stored in memory. Even though she doesn't know which Caesar shift, so she doesn't know what this value is, it doesn't take her long to work out the plain text password by trying all the possibilities. So she's doing a brute force, I suppose, trying every possible Caesar shift to work out what the original plain text was, given that she's read this from her discovered drone. So we've got an explain question here, worth 2 marks, so we need to say the maximum number of attempts and why that's the maximum number of attempts. So first of all, the maximum number of attempts that she's going to have to do is 25. Why is that? because because there's 26 letters in the alphabet, so if it was encoded with a Caesar shift of 0, A would be A, and she'd recognise that straight away. She could try that. The maximum number of shifts she'd have to try is just 25, because then she'd get back round to what she tried first time round. And then one mark for your explanation. You could either write because there's only 26 letters in the alphabet, or you could write because 26 would shift back to the same letter in the alphabet as her first attempt, or you could say because there's only 26 possible combinations. Okay, so your next question, I'd recommend you revise network topologies, a ring, a bus and a star, and all of the different positives and negatives for each. Let's read through the question, highlight the keywords. Feel free to stop here if you want to start it yourself, but I'll just read through the keywords here. We're only going to do the next video 3 part A, so part I and II. A company produces black and white digital artwork and sells it for millions of pounds. It decides to invest in a new computer network, but arguments break out over how best to connect that network. One technician says a ring topology is better, the other says a bus topology is better. So you don't really need to understand this bit. The important bit is always in the question here. Explain one reason why a ring topology network might be better than a bus topology. So you're looking for an advantage of ring over bus, and 2 marks. And then similarly, explain kind of the opposite. Explain one reason why a bus topology might be better than a ring topology. So you have to make a statement and then explain that statement. Okay, so I hope this has been useful. In the next video, we'll go through how to get to the answers for this one. Thanks for watching.